In the name of God. Hello, dear students. My name is Masoud. I'm a physics teacher. We are in Ferhwa's website to explain physics curriculum, grade 12. In previous lessons, we explained, let's say, centripetal acceleration and its relationship with, let's say, tangential velocity and angular velocity. And right now, I'm gonna explain the new subject, which is calculating total acceleration. Let's get started. For an object moving along a circle with a varied speed, look here. I mentioned varied speed. For an object moving along a circle with a varied speed means the object, either the object is speeds up or slows down, right? Maybe object speeds up or slows down. So they belong to varied speed. Increasing velocity or decreasing velocity belongs to varied speed, variable speed. The speed is changing continuously, right? The vector representation of total acceleration is as follows. This is, let's say, a vector representation of total acceleration. So in this situation, when the object moves along a circular track with a varied speed, with a variable speed, means both type of acceleration are present. What are these? Centripetal acceleration toward the center of the circle and tangential acceleration along the tangent to the circular track, like this figure. So this is circular track. The object, let's say, has, let's say, AT and AC simultaneously. And we want to find the, let's say, total acceleration for the object. This is called vector representation. Actually, in vector representation, we have to draw a vector triangle. How do you draw a vector triangle? By means of AT and AC. But here, let's say maybe, and keep in mind that AT, let's say, AT will be the hypotenuse of the triangle. AP will be resultant of the triangle or hypotenuse. Hypotenuse means the longest side of the triangle, like this. This is AT, right? This is AT. And I move AC parallel to itself without changing the direction, without changing the magnitude. So this is AT, and this one, let me draw it by other color. This is AT, and this one is AC, right? I did nothing. I just, let's say, move the object, move the vector. I just moved the AC because for drawing a vector triangle, you have to draw the vectors tip and tail to tip, right? Tail to head, one after another, in order to get the, let's say, triangle. So let's say two sides of a triangle is two sides of the triangle are present, right? We look for the third part, which is the hypotenuse, for creating a, let's say, right triangle. This is right triangle because AC and AT are perpendicular to one another. They make a 90 degree here, and this one is A total. So A total is the longest side. It's the hypotenuse of, or is the resultant of the AC and AT. And this angle will be theta, right? The angle theta means the direction of total acceleration. So this is about the object that, let's say, that moves on a circular track with a variable speed, with varied speed. Angle theta stands for the direction of total acceleration. I told you, it mentions in physics, actually, in physics, theta means direction. Theta or angle determines the direction of the resultant vector. And resultant vector here is A total. It's a hypotenuse, right? Longest side of the of this right triangle. Tip number one, I wrote some tips for it, 3 tips for it. Let me read the first tip. Tip number one, tangential acceleration means AT, right? AT. and centripetal acceleration means AC are what? Are present. Excuse me, are perpendicular. AC and AT are perpendicular based on this figure, right? They are perpendicular. They cut one another and they make a right angle. That's why AT mathematically perpendicular to the AC. The second tip, mathematically, direction of total acceleration. Direction of total acceleration. What does it mean? I told you direction in physics means angle, theta. So direction means theta. Mathematically, direction of total acceleration is found by this equation. Theta is equal to tan inverse AC over AT. So inverse, let's say, of the tangent function is used for find the direction of, let's say, total acceleration. Keep in mind that direction of total acceleration means theta. Theta means direction. Direction or direction. Cool? The third tip, magnitude of total acceleration is figured out by this equation. A total is equal to radical AC squared plus AT squared. This equation is called Pythagorean theorem. So what's the Pythagorean theorem? In a right triangle, right? In a right triangle, magnitude of the hypothenuse square is equal to the summation of the magnitude, summation of the square of the magnitude of other sides. Mathematically, I can say A total, look here, A total square, right? A total square is equal to AT square plus AC square. But maybe you say, teacher, why does this equation, let's say, take this form, right? Because we look for A total lonely, not A total square. So we don't need exponent here for A total. That's why remove the square, remove the, let's say, exponent. How do you remove the exponent? By taking the square root. When you take the square root of the right side, actually you have to take the square root of both sides. In this situation, square root with power, let's say goes away. Square root cancel, let's say, the power, and the right side, let's say, I can say the right side put under the square root, like this equation. A total is equal to radical AC squared plus AT squared. This is called Pythagorean theorem, right? Pythagorean theorem is this equation. So keep in mind that Pythagorean theorem is used for find the magnitude of, let's say, total acceleration, but inverse of tangent function is used for find the direction of total acceleration. Teacher, what do you mean by direction of total acceleration? It means theta. Angle theta is found by let's say, by an inverse of tangent function. But magnitude of total acceleration is found by Pythagorean theorem, right? These equations are very important. I prepared some question for you. Let me read the question related to this subject. Actually, because questions are a lot, I'm gonna finish this lecture here. I will solve the problems in the next video. Thank you for watching this video and see you next video.